Hello everyone, and thank you so much for having me here. My name's Franceska and I'm a first year PhD student at the University of Essex, so this is my first time giving a talk like this. And the working title for my PhD thesis is Mechanisms of Telomerase Activation and Causal Models of Cancer. So just to start with a project overview, that shouldn't be there. So I want to start by analysing big data, and we're going to do that by using really simple statistical testing that we know works, it's tried and tested, and that's going to build the foundation for our hypotheses, which will then test using genome editing techniques. So I have a particular focus on two genes, telomerase and TP53. Both are often implicated in different types of cancer. I think it's been reported that more than 90% of breast cancers have telomerase activation where it shouldn't be activated, and we obviously know that TP53 is a tumour suppressor gene. So just a really quick graphic. I'm going to start with some exploratory statistics and move on to some computational modelling. Then I'm going to formulate my hypotheses. I'm running a pilot experiment at the moment just to make sure that it all works as I think it should, and then we'll move on to the final experimental work to try and actually validate whether our hypotheses are correct or not. So just the agenda of the presentation, I'm going to quickly run through some of the exploratory statistics that I've done. I'm going to talk to you a little bit about the computational modelling that I've done. I'm going to describe a new CRISPR-based technique that you might have heard of called CRISPR-Select, which is how we're running our pilot experiment, and then I'm going to talk through the next steps of my project. So starting with the exploratory statistics. Well, I'm looking at big data. So the data that I'm currently looking at is the TCGA dataset, the Cancer Genome Atlas, which contains more than 20,000 primary cancers, 33 different cancer types, also with some matched normal samples, which could be quite interesting if we manage to get some data out of that. And the data set that I'm currently using is the breast adenocarcinoma data set. So one of the genes that I'm most interested in is telomerase, or TERT. So I started by looking at the correlation between all the genes in the dataset and TERT and their p-value. And in the table, I've got just the top 15 most correlated genes with TERT. Now, in the literature, it's been reported that TERT and TP53 are quite linked, and one of the reasons behind this is that TP53